Welcome back to next part of the coding experience. Last time we talked a bit about the setting up of the environment and everything and what we're going to do. Today, as I said, or last days, I got a bit into the writing some tests and also committed the first, did the first commit, created a branch and everything. So as I said, if you didn't watch the previous video, this is more like a coding diary. So no boring talks about anything else, no prices, no anything, just talking about how I'm trying to implement this DFIP and yeah, what I learned from it. Say this. I created a pull request. So because I moved this documentation from the issue to this pull request now, I have this pull request open. I wrote a test, and in here you see already some changes done. But we will look into the changes in the code. So let's dive into that. I made it a bit bigger so that it can read a bit. It's not finished yet, so the test file is not finished yet. All I did right now is prepare the test file for setting up the chain and everything, but there was already some struggle, and I thought let's share that so that I don't have too much to talk in one video. Generally, as I had before, you have, or as I said, you have in the ain folder, you have the test folder with the functional tests, and in here a lot of Python tests, which are basically all the integration tests, kind of where the Python thing, the framework spins up a local chain, and then you can force it to generate nodes or generate blocks, so it don't have to wait the 30 seconds or anything. It's one chain generating the blocks, blah 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 blah, and you can test it with this one node. So you have your local chain running in the test case, and it basically you can try everything out, create stuff. You have governance right there and everything. So as always, if you do something where you are completely unfamiliar with and have no idea of what you are doing, look for something that in the repository for some code that did the similar thing and try to improve from there. So what I did is I looked into the feature EVM token split test, which is similar thing because it has also EVM, it has a token split, and it sets up the chain and everything. And as you see here, so this is a token split, but I just took a lot from the test. And here it's and that's a common theme in the whole repo for the tests, that you have the setup, then you have the setup of the test parameters for the setup of the node. Then you have the run test, which is basically the thing that's run for this test file, the function. And in there you have a setup. And sometimes after the setup, they set a block to blockade to get back for the rollbacks, to have everything on a clean but set up the same way test case for different test cases, or just different types of chunks. And in the setup, you then have set up the oracles and everything. And I basically did the same. One important thing that took me a while to figure out is this here. Okay, maybe from the start. What you can set here is basically you start up the node with those parameters. And those parameters set the height or override the block height for the different forks. So you have all the forks that we have here, the Grand Central, meta chain, and then after that they stopped naming them names and just give DF for Defichain 23, so that's the fork 23 with the height 150. So at block height 150 in this simulated chain, there is this the fork, and at 105 we have meta chain. Previously, what I tried, or when I started it up, I was like, okay, I'm looking for the DF24 because I pretend now that it happens in the next fork. I think next fork will be by about soon. So this will definitely not be in the DF24, but for now, that's the next fork. So I do that, and I was like, okay, that's what I'm aiming for. I have all the preparations. I set it to 1000, and that's it. And wanted to set this DF23, which is the latest fork with which activated the token split on EVM and everything, or allowed that, to set that directly to a 110. And for whatever reason, and I don't know what's the reason, and I don't want to investigate honestly, for whatever reason, this actually led to an error that the DSD20s on the EVM side were not there and didn't work. No idea why, but yeah, I show you what went wrong, say it this way. Then in the so that's setting up the blockades, and then I do basically the same here. I have the setup, and then I didn't put it into a separate test functions yet, just a setup in the function, and then I will see what I do there, and we talk about that in a second. And my setup block is basically similar to the other one, where I set up the address. So that's the genesis key, so the original my main address. I generate 105 blocks, and that's mainly to get, on the one hand, the block rewards in that address, so you have DFI you can work with in a simulated address, and that those block rewards are also free, because they are not, otherwise you can't use any UTXO, because the UTXO takes some time until you can use it from the time when you get it, the block reward. So you need to generate quite some blocks, but it's fast. It's like that. Then setting up the oracles, pretty straightforward. You have the price feed. I decided now that I put one dToken, and I said SPY, why not? We need the DUSD because it will be renamed, so we need that one. And yeah, and I thought that's it. Let's have, just for test cases, it's enough. Appoint one oracle, get a new address. That's again, I just took that from here. It's basically the same code. And I set the price of DFI to $5 and the price of SPY to 100. Just, yeah, the DUSD oracle is fixed at 1. Yeah, that's that. Generating the stuff. And if I go back, then setting up the tokens. Also, same as in the reference or in the other test cases. Just set. One important thing: if you want to call something in the simulated chain, if you want to call something on the node, an RPC call basically, you just do it like that. You have the method name, and you really can say, okay, self node, because we spun up one node in the simulated chain, so the first node, and you just call this method on the node, and it internally takes the parameters that you give this method and sends that to this method via the RPC, so via the CLI to the node. So it's pretty easy to use to send it. And there, since we have with this node, we have governance, foundation keys. We can just call set loan token, so it creates a new loan token, SPY 500 with the fixed interval price is a dot, and generate one block and get the token SPY, the ID of the token by just again the RPC call, get token SPY. Then we set the loan token DUSD, again generate one, get the key, so that we just have the ID and not only the object. We set DFI as the collateral token, and we set DUSD also as a collateral token with factor 1 and the fixed interval price. And then as foundation member with foundation addresses, we can just mint tokens, and we can mint any tokens, or any dots, I think. So I minted 2 SPY to pretend algo tokens, right? That we can use and move, and 1000 DUSD. Yes, now and also move some DFI from the UTXO to account, so that we have DFI token that we then need in the vault for collateral, because we want to set that up too. Then after setting up the token, I set up the government variables in this case. And there's maybe one thing, because since this generates to 105, we are already meta chain height, so we already have the VM possible. So it makes sense that we now say we activate the EVM, set it to true, enable the transfer domains, and I also set the negative interest for DUSD, so that I can pretend, or that I can build up a DUSD loop there that I then unloop. Wouldn't need the negative interest, but I thought, like, let's have it a realistic example. Also, DUSD vaults need to be enabled, and the loan payback collateral, so payback with collateral, are also activated. That mainly because I simulated it with that. I think this one would not be necessary, but it's currently active, so it's fine. And then we move to the DF23 fork to get the DSD v2, because there was an update, and you will see now why I did this, because now also gonna take from here. I also take the contract address from the SPY, the v1 that we get, because it's a token with the 81 and token with the 82. To make it a bit nicer, we could use here directly the ID, the variable, but it's always the same, so it doesn't matter. Get the DSD20 versions. I think this one is not even necessary, but I just copied it over, so yeah. And then check that the DUSD contracts are there. So we create a we say there is a contract with this ABI on the DSD address, and check if this contract has the DSD name and symbol. Same with SPY. And this, when I didn't do this, didn't have the time here, the 50, so from 100 to 5, if I go to 110, this call, where is it? Where's again? Where's my setup? So when you move around here, this check that I call this function returned the null pointer, so a EVM null pointer, which means it's just not there, right? So the contract was not there. No idea why, and honestly, for this now I don't care. So as long as this is fine, I'm fine with it. Yes, and this is the variables, so that I now have also the DUSD contract and this SPY in, and check that this is in, and this is all correct. And then in the setup, I do 2 or 3 more things. One, I move EVM funds right here. I say, okay, again, just a RPC call. I transfer 0.5 SPY from the stuff that I minted to an EVM address that I created. Maybe let's look at the EVM address. Yeah, I created it here, like get new address. RPC call, done, nothing special. So I move 0.5 SPY so that we can then also check that funds on the EVM are not touched, and also check what's happening when you send old SPY back down to the DVM, that it's then correctly locked and converted. And the same with DUSD, because current DUSD, old DUSD needs to be there. And then there's 2 more things that I do. I move now the chain to block 500, so that I have a reference block, because in between there you always see you generate one block to get this transaction into the block, right? You need to confirm that all the transactions that you can work one after the other. So I generate it and go to 500, so in case I change anything beforehand to add something here, I still have 500 as a reference block before I start the vaults and the pools. Because when you create the vaults and I create the loan and everything, then the interest starts to accumulate. And when I then check the numbers of the vaults, if they are fine in the test, they need to be always the same, so they need the same amount of blocks between them. That's why I have here a reference height that I say, okay, always go to 500 no matter what happened before, and then set up the test vault. where I create a loan scheme and create a vault. For the first I create a normal vault and I create a vault that should be a loop. Deposit 100 DFI and 10 DUSD to the normal vault and 150 DUSD to the loop vault. Generate a block so that we get that all in. And then take 100 DUSD in the loop vault as a loan, because 150, 100 maximum, and deposit that right away. So we don't do a lot of looping, just one loop, so that we can unloop it then. Take loan and deposit, and the normal loan take 2 SPY loan on the 100 DFI and 10 DUSD. I added both there because I want to test then that I say, okay, parts from the funds will be from the address that pay back the loan. Then we have DUSD in the collateral that should be used to pay back the loan. And then we have DFI in the collateral because the DUSD is not enough to pay back the loan. So it should then use the balance, then not enough balance, take DUSD from the collateral, not enough DUSD in the collateral, take DFI from the collateral, and that's basically, and then it moves on to BTC or whatever is still left in the collateral, but that's the different things there. I think that's it's all crypto then, so it's all composite swap down to into the dTokens. One thing that I'm currently considering or thinking of is that we need to make sure that people close their loans before this is activated. Because if this all gets converted automatically, we would have a lot of buy pressure on the DUSD right on this block. So it would be far better or far clearer on for the whole system if everyone closes their loans beforehand. And within the dToken system, so if you we need to use DUSD to pay back the dToken loans, it's likely better on a development standpoint and from integrity of the system that we don't swap it on the DEX, because then a low liquidity pool might go completely out of bounds, but better use the DUSD future swap basically without a fee, and directly swap it for the overclock price on the block, move it directly over and do that. But yeah, I think that's some implementation details how this loan is paid back with the collateral. But I think in the dToken system, future swap, temporarily future swap would be the best way, because then you don't have the question who is swapped first, because if there's low liquidity with 4 million or 2 million in open dToken loans, there will be a lot of might be a lot of swaps. But best case, people close the loans. So something to think about down the road. But now I set up the test, so we have a loop vault and we have a normal loan in the vault, and then I also set up the test pools because they need also to be converted. And I thought, let's create one gateway pool and one normal dToken pool, SPY USD, commission, and that's a normal symbol, and one gateway pool, the DUSD DFI pool, again, normal commission and everything. So, and I get the symbol ID, and I add liquidity from my address so that I have the liquidity tokens, DUSD DFI and SPY DUSD at the correct prices right now. And that's it with the setup. And then the only thing that's left is what I did after the setup. I basically added the test, and I think to make it more readable, I need to put that in a function that checks the expected initial state. Just that we have a reference also, where I said, okay, I get the vault, and then check if this vault, this here I should put the owner address of the simulated chain. It's a variable, but it's always the same, so it doesn't matter. But here I check that I see, okay, what's the collateral? You see the loan is already reduced by the interest, and I didn't only check specific numbers here, because I usually prefer to have more checks on the thing than less, because then it's easier to not miss anything if now something changes in the stuff. And I checked that vault, I checked that vault, and I checked the account of the address. And here again, the whole account and not just one specific token, because I want to make sure that there is nothing, no additional token there, and only the ones that we want. So that's after the setup, after sending funds to the address and everything. And here also check the balance on the EVM side with the SPY contract, 0.5 SPY in the EVM address and 40 DUSD in the EVM address. And in the pools, we have the reserve and the reserve A, the reserve B in the pool with all the stuff in the DUSD pool and the SPY pool. Yes, that's so gateway pool and dToken pool. And then, so that's now the initial state, everything checked. And then theoretically here we move to the forkade where the restart would kick in right away. And now we need to check the other stuff. So I have here a lot of explanation what's should happen. And then I added here numbers for the stuff that is likely to be the correct numbers or close to it, but we will need to see when this all happens in one block, what's the exact numbers there in the unloop because of the vault, and in the payback collateral, how much collateral is left in terms of the DFI, because some of the all DUSD, and that's just a reference, in my opinion, or for me the reference now. I say, okay, all loans should be gone, all DUSD from the collateral should be gone, and from the DFI, some DFI from the collateral should be gone to pay back the loan. And then it's close enough, but the exact number is a bit uncertain. For the pools, the DUSD DFI pool, on the one hand, I don't have to check here for the old pools because the normal token split, the old pools are removed. It's not that the existing pool ID gets converted and you have new tokens in the existing pools, but new pools are created. The old pools are just gone or just empty, completely emptied out, and the new pools, there are new pools created. And so I will do that the same here, because stick to the best practices or the consistency. And I didn't add checks for old pools to be empty in this case. But now you have the new pool, and the new pool should have 44. So this is already assuming the swap, assuming the DFI to DUSD swap or USDD swap, then to pay back the collateral, because before and then, so swapping and then removing, because before we had 500 to 10, and then I assume that some DFI came in and they got out, and then 90% got removed. So from 500 to 10, I expect it to move to around 11 point something to 440, and then 90% removed, so 44. So it should be in that, close to that range there. And here I assume that within the system the payback is with a future swap, so direct conversion. So you pay back the SPY with the USDD amount. So the USDD is burned or removed for paying back the SPY, but we'll need to check what's the better way to implement it, just implementation wise. And so that's the assumption, that this stays. But again, from wait a second, 2 to 200, it should be actually 20, 0.2 here, because because this is also down 10%, 90% gone, so it should have that in the reserve, and my funds in the pool are also 10% or what I had before. The DUSD funds are 10% from what I had before. This is from conversion. I think this is not correct now. This is likely because we are not swapping anything in the DUSD. So this is 1, 2, 3, 4, 5, 6, 7, 8. So this is that, and the DFI. There is likely going to be add commission payback swap, because swapping then on the real chain or on the pool, so it you have the commission there. So there will be some commission coming in, but the DFI not changed. 390 compared to the 390 we have here, but that's not true because we likely have how much 44 that's likely a few, because 11 in and you get 9 out, so let's, I guess, just 99. Add commission from swap, added DFI pool, because the DFI from the pool come to the address, directly to the address, and the others are locked. So that's roughly what I expect, and if that's right, that's what I want to check right after the restart. So after this happens, and then later I also need to check or add tests to check the amount in the logs of USDD and SPY, check the release ratio, the total locked funds, maybe add that to a governance economy, gov entry, also an attribute, and the correct behavior of a transfer domain when old SPY and the DUSD are converted down. And I also want to add a second address which has less SPY in the loan than the balance, so that there's still SPY left in the balance that then locked. And then also do a normal token split, because we need to make sure that the token split on the new thing works. Or it works still after token split, so the smart contract balances are also correctly matched in the split for normal token split, and check the correct behavior on DD if an old SPY is converted down and then locked up and then split. So that's important to have that also in there. Then release a tranche, check balances, and check if the transfer down also does the correct new behavior, the correct new ratio. So that's the plan for the addition of tests, the current test. The only thing left that I changed is, on the one hand, in the test runner, because here you have all the tests that should be run, and if you want to run the test, you need to add the list here. They are sorted by the time it takes to run them. I just added it here now with a to-do, because I don't know how long this test will take once it's ready. And one thing, if you want to implement it or want to use or do stuff on the repository, whenever you want to push, they added a pre-push hook that run make sh check. And on the one hand, that's for formatting and everything, and this makes perfect sense. But it also does something with cargo, with the Rust compilation and something. And it seems I don't have cargo installed. I can compile Rust and everything, but it just has some problems. So that I'm able to push now in my local repository, or not local, in my own forked repository, I just disabled that for now, so that I can work with it. Yes, and with that, let's just also run it and not make the video too long, because now I'm running, as I said last time, make sh test pi and filter for just this test file. And of course it failed, because but we can look where it failed, and you see it fails after the fund. So all this asserts before work, and here now this vault, we expect this vault to have, we expect it to have a 15 in there and no loans or interest anymore, because it should be unlooped. But actually there is interest, there is loans in there, because nothing happened on this block. So just stuff occurred. So that's why it fails. Make your test fail, because that's what we want to change now. But also the good news, all the things before, all the checks here that the balances in the setup are correct, they are all fine. So the setup of the test is fine, the preparation of the test is fine, and now all that's there to do is implemented. So easy as pie, right? Yes. Let's see. I will look into the implementing now, and once I have something, I will make another video. This one is already 30 minutes, so sorry for that. Maybe watch it with 2x or something. But if you're interested, see you in the next video. If you have questions or anything, leave a comment. I know those videos are not so much for my usual followers, so I see that not many people watch them. But anyway, maybe it helps some, and if not, then it's just for me to be accountable and to actually do it. So with that, see you in the next video.